In this video, we're going to talk about complex numbers. It's something that you kind of learn in algebra once upon a time, and then you don't see it for a while, but then you come back to it and you expect to remember about it. So this is a quick overview here. First things first is that when we have I here is the square root of -1 that you're used to. In electrical engineering, we don't use I for that anymore. We instead use J. So everything from here on out, you're going to see J for the imaginary number. It's to help us so we don't get confused with I being current. Now, it doesn't really matter if you use I or J, but you're always going to see in your electrical engineering books that's J everywhere. So I will usually stick with that. Now, when we're solving rectangular form or polar form, these are just different ways of writing our number down. For example, if I had the number written as 3 plus 4j, that just means that in the plane here, you go 3 right and 4 up. And that's the number 3 plus 4j. It's the way you're probably most used to writing complex numbers. And it's perfectly fine to write them that way, but we'll see why the polar form is also useful. An example of a polar form problem might be something like 5 angle 90 degrees. And what that means is you start in the positive x direction. You go whatever angle they tell you, in this case 90 degrees. And then once you've gone that direction, then you're going to go that many units, 5 up here. So that would be the point 5 angle 90. Now we use this angle notation, but another way to write this that you may have seen before is E, right? They use e to the I theta, or for us j theta, so e j 90 degrees. It's another way of writing this here, the same number. Also in fewer textbooks, they will write CIS, and that's supposed to be cosine plus I sine. Because there's this famous thing called the Euler identity, which is that e to the I theta, or for us j theta, is cosine theta plus I sine theta. So we just write this with the angle notation. It's a little bit shorthand for it, but it's the same kind of idea for polar. Now, if you want to convert back and forth here, we have these 4 formulas that you can use. So the easier way is if they give it to you in terms of polar and you want to convert, you use x is r cosine, y is r sine. So I'd have x is 5 cosine 90. That's going to be 0 because cosine of 90 degrees is 0. My y is 5 sine of 90, which is 5. So x plus jy is going to be 0 plus j5, or just 5j. So that's the number 590. If you convert to rectangular, it's 5j. On the other hand, if you have 3 plus 4j and you want to convert it, you can find the r without too much trouble. 3 squared plus 4 squared is going to work out to be 5. And then you have tangent theta is y over x, 4 over 3. Now here's the problem. First off, it's not going to be a particularly nice angle here, because 4/3 is not the tangent of any of the nice points on the unit circle. However, you also are probably going to use to just using inverse tangent, and you would get the right answer here, which is 53.1 degrees. But I do want to warn you that inverse tangent is only going to give you the right answer when you are on the right side of the unit circle. That's because the output of inverse tangent is always between -90 and +90 degrees. So that means if you're on the left side of the unit circle, you have to use the idea of reference angles, adding, subtracting pi, or whatever to get to the right answer. It's just something to keep in mind when you ever are converting things into polar, which you likely will be doing. And so that means that the answer here would then be 5 angle 53.1 degrees. Now, when you are adding and subtracting complex numbers, let's say I have 3 plus 4j plus 2 minus 7j, it's really easy to add them when written in rectangular form. You add the real components, 3 plus 2 is 5. You add the imaginary components, 4 minus 7 is negative 3, and you get your answer. On the other hand, if you have things like 5 angle 20 plus 3 angle 40, there is no good way to just add them together. There is no rule I can tell you. In fact, if I had to add those two things, I would convert them to rectangular and then add them. So adding and subtracting is by far better in the rectangular format rather than polar. On the other hand, if you want to do multiplying or dividing with rectangular, you have to do a bunch of foiling here. 3 times 2 is 6, minus 21j, plus 8j, minus 28j squared, and then you do some simplifying, all that fun stuff. Even worse, if you had to divide these, you may or may not remember that the way you do that is you multiply by the conjugate, and then you do a bunch of work there. On the other hand, if you want to multiply two numbers in polar form, it's incredibly easy. You multiply the front numbers, 5 times 3 is 15, and then you add the angles together, and that's it. And the thing is, if you're dividing them, you just divide the front numbers and subtract the angle. So let's say I did 3 angle 40 divided by 5 angle 20. 3 over 5 is 0.6, and 40 minus 20 is 20. So when you're multiplying and dividing, it's better to have it in polar form instead of rectangular. And lastly, if you have powers, let's say you have something like 2 angle 15 degrees, and I want to raise it to the 4th power. If you had that written in rectangular coordinates, it'd be a gigantic pain to take a 4th power of a binomial there and then simplify it. But it turns out, because powers are just multiplying, you can just power the first one. 2 to the 4th power is 16, and then you multiply the angle times 4, and you get 60 degrees. So powers are another thing that are much better in polar form. So this video is just to remind you about the basic operations with complex numbers, as well as how to convert between rectangular and polar. And you really want to just be kind of second nature at this when you're doing these problems involving complex numbers. I will say that TI calculators and other calculators can do this conversion and can do all these operations for you if you know how to put them in the calculator right. So it'd probably be a good use of your time to go ahead and practice that so that you can do these in your calculator, and it will help lower the number of mistakes you make.